Hello and welcome to Live at Pulse for the second part of the GED Science practice test. In the last video we stopped at question 12. That was the last question that we answered, so we continue with question 13 and we will go up to question 25 in this video. So let's get started. Question 13. Behavior is the way in which organisms interact with other organisms and their environments. In both people and animals, behavior occurs in response to an external stimulus and internal stimulus, or both. Some behaviors are innate or built in. These innate behaviors include reflexes and instincts. Other behaviors are learned as a result of experiences. Which of the following is an example of a reflex? A person blinking when something is thrown towards him or her, a baby crawling on the floor before it begins to walk, a bird gathering material to build its nest, a dog barking when it hears a doorbell. So the only thing that is a reflex here is the blinking of the eye. This is something we can't really control. If something flies towards our eye, we blink. We don't learn this. It's an innate behavior. It's a reflex. The purpose of it is to protect our eyes when something flies towards it. All the others are examples of learned behavior, so therefore we can exclude them. They are not reflexes. So next paragraph is needed to answer question 14 to 60. A teacher is showing experiments in magnetism to the science class. She gets two 4-inch long magnetic bars. The north poles of the bars are painted red and the south poles are painted blue. She has her students write down the observations about what happens when she lines up the magnets with the north poles near each other. Then she has her students write down the observations what happens when she lines up the magnets with the south poles near each other. Finally, she has her students write down the observations about what happens when she lines up the magnets with one north pole and one south pole near each other. For the second part of the experiment, the teacher takes one of the bar magnets and rubs it along the length of a steel ruler for several minutes, always in the same direction. She then holds the ruler over a paper clip to show that the ruler has now been magnetized and will attract the paper clip. In the third part of the experiment, the teacher takes a long piece of copper wire and coils it. She attaches each end of the wire to the base of a small low wattage light bulb. She then passes one of the bar magnets through the middle of the wire coil and has the students record the results. In the second experiment, so we are in this paragraph here. In the second experiment, why does the steel ruler become magnetized when the bar magnet is rubbed along the ruler's length? So this implies some knowledge about magnetism. The magnet causes the electrons in the ruler to line up in the same direction. The pressure on the ruler causes it to oppose the polarity of the magnet. Small bits of the magnet rub off onto the ruler, and those particles are what make the ruler magnetic. Steel is already magnetic, and the magnet reverses the polarity of the ruler. So the steel ruler, so first of all we can exclude the last one, because without rubbing the steel ruler with a magnet, it is not magnetic. It doesn't attract any paper clips, but afterwards it does. So D is definitely not correct. So it's either A, B, or C, and the correct answer here is A. Magnetism is directly related to electrons and their orientation, and if we slowly rub with a magnet always in the same direction along the steel ruler, the electrons start to line up in the same direction and the ruler becomes magnetic. Pressure has nothing to do with magnetism, and no small bits of the magnet do not rub off onto the surface of the steel ruler. So we are looking for the correct diagram, A, B, C, or D. Which diagram could illustrate the field lines created around the poles of the magnetic bars when they are placed near each other? So therefore we need to know two things. This is about experiment 1, although they don't really tell us what happens in experiment 1, we need to know this. So I hope you know that if the north pole of the magnet is close to another north pole, they will repel each other. Whereas, same for south pole and south pole, that's true as well. Whereas when we have a north pole and a south pole next to each other, they will attract each other. So we can represent this with magnetic field lines as well, and therefore we need to know the definition of field lines of a magnet. Magnetic field lines always go from north pole towards south pole. So either two magnets that attract, like this, or if we have just a single magnet on its own, north pole, south pole, then it has field lines as well that look a bit like a circle going around the magnet and so on. And again, here the lines would always go from north to south. So if we look at the diagrams, we can see that we have at least the attraction between north and south. That is correct. However, we can see that in this case the arrows on the field lines go from south to north, so therefore A is not the correct image. B, we can see north pole and north pole next to each other, and we can see that the field lines don't connect because they repel, they go away from each other and they will not cross, they repel, and we can see that the arrows point away from the north pole, so therefore B is probably correct. C is wrong because north and north do not attract, and D is wrong because the arrows go away from the south poles. To make this correct, the arrows should go towards the south pole. So the correct answer here is B. Which of the following accurately predicts what will happen when the magnetic bars are passed through the middle of the wire coil? Now, when we pass a magnet through a wire coil, this will induce a current in the coil. So the south poles of the magnets attract each other, an electromagnet is generated, the light bulb lights up, the north and south poles of the magnet repel each other. So the light bulb will light up because a current in the wire is induced. Question 17 to 18. A physicist is conducting an experiment regarding the momentum of objects in motion. She has a car, a baseball, a snowball, and a hockey player on ice skates ready to move. Each of the objects is set in motion and its velocity is measured. The momentum of each object is then calculated. Next, the moving objects are set two at a time to collide with each other head-on. Which of the following has the greatest momentum? So first of all, we need to know how to calculate momentum. Momentum is equal to mass times velocity. So the greatest momentum, this is the mass, kilograms, and velocity in meters per second. So 1,100 times 20, or 0.145 kilogram times 35, 0.3 times 1500 times 10. So we don't really need to do the calculations. We can see that the largest number we will get by multiplying 1,100 by 20. That will give us the largest number and therefore the largest momentum. Which pair of objects will demonstrate conservation of momentum when they collide with each other? The hockey player and the baseball only, the car and the baseball only, none of the objects, all of the objects. Now, whenever two objects collide, the momentum might be transferred from one object to the other. So we can have one object that rolls towards another object that is stationary. When the objects collide with each other, then both of them might move in the same direction. So the total momentum in this system, which means at the moment this one has a momentum of 0, and let's say this one has maybe a momentum of 100 kilogram meter per second. This one has 0. Then down here, the combination of the two has to be equal to the total momentum here. That's what we call conservation, keeping things the same before and after. And this is always true about a collision. Every collision, momentum will be conserved. So in this case, that could maybe be something like 40 kilogram meter per second, and this one would then have 60 kilogram meter per second. And we can see that 40 plus 60 is equal to 100 plus 0. So 19 and 20 are based on the following information. For the school science fair, Evelyn wanted to determine the optimal amount of water for marigold plants. She planted the same number of marigold seeds in each of 30 pots. She divided the pots into 3 groups with 10 in each group and labeled the groups A, B, C. She wanted the plants in group A. She watered the plants in group A daily, group B twice a week, group 3 C once a week. The plants received an equal amount of water each time. She predicted that the plants watered daily would be the tallest at the end of the month. Which of the following would not be necessary for the experiment to be valid? Using the same sized pots, including a control group, planting all of the seeds in the same type of soil, making sure the plants received an equal amount of sunlight. So using the same size pot is probably important so that all plants have the same amount of soil, including control group. That is probably the correct answer here. Planting all the seeds in the same type of soil, yeah, that's important too, so they have the same types of nutrients and things like that to grow, and making sure the plants receive equal amounts of sunlight makes sense as well. Otherwise, different amounts of light would lead to different growth. But we are interested in how the water affects the growth. So the control group is needed in most experiments because the control group gives us something like a base value, a normal that we can compare our experimental groups to. But in this case, yeah, we are just watering plants at different schedules. There's no normal amount of water that plants usually get daily, so we can just take our 3 groups and compare them to each other. Control groups are important, for example, in medicine when we study the effect of a drug. Then we always need a group of patients that don't receive the drug but are receiving otherwise the exact same treatment. So they receive like a pill that has no effect medically, and another group receives the drug that is tested, and then in the end we can compare the 2 groups to each other. So their control group is very important. Here it is not that important. The watering schedule Evelyn used in the experiment is so that's what we change on purpose. We're changing the amount of water the plants receive on purpose because we want to see the effect of the different amounts of water on the plants, and therefore this is the independent variable. Now, the independent variable is what we are testing, it's what we are changing on purpose. The dependent variable in this case, in general, the dependent variable is what you measure. So the dependent variable is the size of the plant that is measured in the end, the outcome. Laura accidentally dropped a book that she had been holding up in the air. The book weighed 2 kilograms. It fell 1.8 meters to the ground, making a loud noise when it hit. Assume that the acceleration due to gravity is 9.81 meters per second square, and gravitational potential energy is equal to mass times gravitational acceleration times height. How much potential energy did the book possess while in Laura's hands? So we just have to multiply these numbers together. 2 times 1.8 times 9.8. So that should be round about 1.8 times 10 more or less is 18, times 2, 36, a little bit less because 9.8, so the correct answer is A, 35.5 joules. The calculation that we're doing one more time is 2 kilogram times 1 or times 9.81 meters per second square times the height 1.8 meters, and that gives us gravitational potential energy. As the book fell through the air and eventually hit the ground, the potential energy was destroyed and kinetic energy was created. Sound energy was created. The potential energy and kinetic energy were destroyed. The energies of the system were converted from one form to another. So this plays or assumes that you know an important definition, or an important law, the law of conservation of energy, and this law states that energy cannot be created or destroyed. It can only be converted from one form into another. So therefore the correct answer is D. When the book is falling, its gravitational potential energy, its stored energy, which we calculated was 35.5 joules, will be converted into kinetic energy because it's accelerating while it's falling. When it hits the ground, the kinetic energy of the book is converted into sound energy and some heat energy as it impacts the floor. So in the last 3 questions for this video, the physical structure of Earth includes 3 basic layers. At the center of the planet is a solid, very dense inner core surrounded by a liquid outer core. The outer core, which contains iron, spins as the planet rotates, generating a magnetic field as it flows. Together, the inner and outer cores are approximately 2,200 miles thick and make up about 1/3 of Earth's mass. The core is covered by a layer called the mantle, which is semi-solid, and although it is not the hottest layer of the planet, it is still so hot that some of the rock in its layer is molten. The rock flows slowly, similar to hot asphalt. The mantle is covered by a rigid outside layer, or the crust. This layer is about 25 miles thick beneath the continents and 4 miles thick beneath the oceans, which is relatively thin compared to the other 2 layers. The uppermost part of the mantle is cooler than the deeper parts and combines with the planet's thin crust to form the lithosphere. This layer has broken into pieces known as tectonic plates, which are constantly moving as they float on a layer of molten rock. The asthenosphere is part of which layer? So here we see the asthenosphere, and here we see the mantle, and we can see that the asthenosphere, which is this layer, is part of the mantle. Which layer of Earth is responsible for a compass pointing towards north? We read that the outer core, which contains iron, spins as the planet's planet rotates, generating a magnetic field as it flows. So therefore, the outer core is responsible for generating the magnetic field, which will cause a compass to point towards north. Beneath which location is Earth's crust the thickest? So we can see the different locations here. The dark gray part is the crust, and we can see different examples here of where it could be the thickest. Atlantic Ocean, definitely not, because we have read that the layer is about 25 miles thick beneath the continents and 4 miles thick beneath the oceans. So then it's either the Grand Canyon, the Mojave Desert, or Mount Everest, since Mount Everest is the tallest mountain, and we can see that the mountain range, here the mantle, this is where the mantle is thickest. We can assume that it must be thickest at Mount Everest. Grand Canyon, relatively deep, so it's going to be thinner there, and Mojave Desert as well. So that's it for today. I hope I could help you to prepare for your GED test, and I will see you for the next part. Until then, have a good day.